Welcome to the deep dive, everybody. Today, we're taking a deep dive into the world of infrastructure as code, specifically Terraform.
Right.
We're using excerpts from Mastering Terraform and Terraform in Depth. And, clearly the listeners have a thirst for knowledge in this area, so
Yeah,
let's get right to it.
absolutely. And whether you're prepping for, like a big meeting or just starting to explore this world,
Yeah.
we're here to help you understand, the core concepts of Terraform
Yeah.
and its place in the world of IAC.
Yeah. So you've got these two great resources. You've got Mastering Terraform and Terraform in Depth. Let's just start by talking about the why of it all. Why did IC emerge in the first place?
Well, imagine a world where every server, every network configuration, every firewall rule was set up manually.
Right.
It was a time of headaches, errors, and late nights.
Oh, yeah.
As systems grew more complex, this manual approach simply became unsustainable. And that's where IAC came in. IAC came in promising a more efficient, reliable, and repeatable way to manage infrastructure.
So it's about moving away from clicking buttons in a web console
Yeah.
and towards defining everything in code.
Precisely.
Yeah,
IAC allows you to treat your infrastructure like software. You can version control it, test it, and automate its deployment just like you would with your application code.
I see. And Terraform is, one of the key players in this whole IAC
Right.
revolution, but it's not the only tool out there, right?
No, you're right. There are other IC tools, each with its strengths and weaknesses. What's fascinating about Terraform is that it's become somewhat of an industry standard, right? It's mature, it boasts a large community, and importantly, it's cloud agnostic.
Right?
You can use it to manage infrastructure across AWS, GCP, Azure, and many other platforms.
That's a huge advantage. I'm already seeing how powerful this can be for teams working with diverse cloud environments.
Absolutely.
But what sets Terraform apart from these other IAC tools?
Well, one of Terraform's key differentiators is its declarative approach, right?
Yeah.
You describe your desired end state.
Mhm.
For instance, I want a web server with these specifications,
Right.
and Terraform figures out the steps needed to make it happen.
Yeah.
It's like giving Terraform the blueprint, and it acts as the skilled architect,
Yeah.
bringing your vision to life.
That's a great analogy. And it sounds much more intuitive than, having to manually define
Oh, for sure.
every step of the process.
Yeah, it is. And this declarative approach has a ripple effect, right? Think about the concept of modules in Terraform. They're essentially reusable blocks of code that represent common infrastructure components, like a database cluster or a load balancer.
So instead of reinventing the wheel each time, we can create these pre-built modules and reuse them across different projects, right?
Exactly. Modules foster collaboration, efficiency. They also make it easier to ensure consistency and best practices across your infrastructure. It's a key part of what makes Terraform so powerful.
Okay, so I'm starting to get a sense of the big picture here, but let's zoom in a bit. What are the fundamental building blocks that make all of this possible in Terraform?
Sure. Let's break it down.
Okay.
At the core, we have HCL, which stands for HashiCorp Configuration Language. It's the language you use to communicate your infrastructure desires to Terraform. HCL is designed to be human-readable and easy to understand, even if you're not a seasoned programmer.
So HCL is how we tell Terraform what we want.
Yeah.
But how does Terraform actually interact with different cloud platforms? That's where providers come in, right?
Absolutely. Providers are like the bridges connecting Terraform to your chosen cloud platforms,
Right.
Like AWS, Azure, or Google Cloud. Each provider has its own terminology and features reflecting the specific services and capabilities of that cloud platform.
So for instance, if I wanted to create an S3 bucket in AWS,
Yeah,
I would need to use the AWS provider in Terraform.
that's right. The provider acts as an intermediary, translating your HCL code into API calls that the cloud platform understands.
It's all starting to connect now. We've got HCL, providers, and modules. What else is crucial to understanding how Terraform works under the hood?
Well, one of the most intriguing aspects of Terraform is its use of directed acyclic graphs, or DAGs,
Okay.
to model the dependencies between your infrastructure resources.
Okay.
It might sound complex, but think of a DAG, like a flowchart, that visually represents what needs to be built and in what order.
So for instance, if my application depends on a database,
Right.
the DAG would ensure that the database is created before the application attempts to connect to it.
That's a great example. Terraform uses DAGs to ensure that resources are created, updated, and destroyed in the correct order. preventing all sorts of potential headaches and errors.
It sounds like Terraform is taking care of a lot of the complexity behind the scenes,
Yeah.
freeing us to focus on the, higher level design of our infrastructure.
Exactly. But there's another critical piece of the puzzle that we need to discuss. State management. Terraform keeps track of your infrastructure's current state in a file called the state file. This file is like Terraform's memory.
Okay.
It remembers what resources have been created, their configurations, and their dependencies.
So it's basically like a snapshot of our infrastructure as managed by Terraform.
Right.
Why is this state management so important?
State management plays a vital role in Terraform's ability to make efficient updates and prevent unintended changes.
Okay.
For example, if you modify your Terraform code to change a server's configuration, Terraform can compare the new desired state with the existing state stored in the state file.
Right.
This comparison allows it to determine the minimal changes needed to bring your infrastructure into sync.
It sounds like the state file is like a crucial piece of the puzzle, but it also sounds like it could be like a potential security risk
Oh, yeah?
if it contains, sensitive information.
That's a great observation. Security is paramount when it comes to state management. We'll be delving into best practices for securing your state files and strategies for managing them effectively in later parts of our deep dive.
Okay.
But you're right, it's a critical consideration.
This is all incredibly insightful.
Oh.
We've laid a solid foundation. We explored the why behind IAC, the key features of Terraform, and those essential building blocks like HCL, providers, modules, digs, and state management.
Yes, we've covered a lot of ground. It's a testament to how powerful Terraform is, but also how it's designed to be approachable and manageable, even as you delve deeper into its capabilities.
Well, I'm definitely eager to learn more.
Good.
And in part 2 of our deep dive, we'll be shifting gears from foundational concepts to practical applications and some of the advanced techniques that make Terraform so versatile. So stay tuned. Welcome back to the deep dive. In the last part, we explored all those foundational concepts of Terraform and all. Now, let's shift gears a little bit and see how these concepts actually translate into those real-world scenarios.
Yeah, Terraform in depth really stresses this crucial aspect that often gets overlooked when teams start using IAC, and that's security. It's not enough to just automate the creation of your infrastructure.
Yeah.
You need to make sure that it's secure from the ground up.
That makes sense. You wouldn't build a house without considering things like locks and alarms, right?
Right.
So how do we bake security into our Terraform code?
One of the most important aspects is managing secrets effectively.
Oh.
We talked about variables earlier, right?
Right.
Well, imagine those variables containing sensitive information like database passwords or API keys.
Right.
You wouldn't want to hard code those directly into your Terraform code, right?
Oh, that'd be a recipe for disaster. Anyone with access to the code could potentially see those secrets.
Exactly. So instead, we use techniques like storing secrets in dedicated secret management tools like HashiCorp Vault or, leveraging the secret management features provided by our cloud provider.
Okay.
This way, the secrets are stored securely, and Terraform can access them without exposing them in plain text.
So it's all about keeping those secrets locked away in a safe place and giving Terraform a way to, retrieve them without compromising security.
Precisely, yeah. And this leads us to another important security principle, the principle of least privilege.
Okay.
This applies to both traditional infrastructure and IAC. It means granting resources only the permissions they absolutely need to function.
I see. So we're not just thinking about what resources we need, but also limiting their access to prevent any potential misuse or unintended consequences.
Exactly. It's about minimizing the attack surface and creating a more secure environment overall.
Okay.
Now let's shift gears a bit and dive into a concrete use case that both our sources explore.
Okay.
Building a custom Terraform module
Okay.
to manage TLS certificates.
Ah, certificates. Those are essential for secure communication over the internet. I've always found them a bit mysterious, so I'm eager to learn more about how Terraform can help with that.
Yeah, they can be tricky, but Terraform makes it much more manageable.
Okay.
Think back to the idea of modules, right?
Okay.
Creating a dedicated module for managing TLS certificates allows us to encapsulate all the complexity and best practices into a reusable component.
So if we need to set up TLS certificates for like multiple applications
Yeah.
or across different environments, we can just use this module without having to reinvent the wheel each time.
Absolutely. And mastering Terraform kind of walks us through the process of building such a module. The first step, as with any good engineering project, is research, right?
Right.
We need to understand the requirements, identify the available resources, and consider any security implications.
Okay, so it's not just about like diving straight into writing code. We need to lay the groundwork and like actually understand the problem we're trying to solve.
Exactly. Mastering Terraform really emphasizes this planning phase.
Okay.
And as we build our TLS module, it's also a good time to revisit those best practices that we discussed earlier.
Right.
For example, using clear and consistent naming conventions for our resources and variables.
Right, because good naming practices just make our code, more readable, more maintainable, especially when we're dealing with something as potentially complex as, TLS certificates.
Absolutely. Now, as we build our TLS module, we'll likely encounter situations where we need to introduce some logic into our Terraform code.
Right.
And that's where conditional expressions come into play.
So instead of having like a fixed set of instructions,
Yeah.
we can make Terraform's behavior depend on certain conditions.
Exactly.
That sounds powerful.
It is. It is. Mastering Terraform provides a great example, right? Enabling or disabling a specific resource based on an input variable.
Okay.
So let's say our TLS module has a variable called enable TTP2.
Okay.
If it's set to true, we would create a listener that supports HTTP2.
Right.
If it's false, we'd stick with, standard HTTP.
I see. So it's a way to like customize the behavior of our module based on like specific requirements.
Exactly. And mastering Terraform also introduces us to the world of Terraform functions.
Okay.
There's a whole library of functions available
Right.
for manipulating data, performing calculations, and making our code more dynamic.
Functions. They sound like the secret weapons in a Terraform expert's arsenal.
Yeah, they are. They're incredibly powerful tools.
Okay.
Terraform in depth provides a fantastic example. Using the template file function to dynamically generate custom user data scripts for cloud instances.
Wait, user data scripts. What are those?
So think of user data as instructions that run when a new cloud instance starts up.
Okay.
They allow you to customize the initial setup of the server, install software, configure settings, and so on.
So instead of like manually configuring each server, we can use these user data scripts to automate the process.
Precisely. And with the template file function, we can create these user data scripts dynamically, incorporating variables and logic to tailor the configuration to different instances or environments.
That's a brilliant way to like streamline the provisioning of our servers. It's all starting to like come together. I'm also curious about how Terraform handles situations where we need to create or manage, multiple resources of the same type, like a cluster of web servers.
Right.
Do we have to write the same code over and over again?
That's a great question. And this is where Terraform's looping capabilities come in.
Okay.
Terraform in depth provides some really clear examples of how to use the count and for each meta arguments to create or manage multiple resources efficiently.
So let's say we need to create, 10 identical web servers.
Yeah.
Instead of, writing the configuration for each server individually, we can use count or for each to like loop through a set of values and create those servers dynamically.
Exactly. And this looping capability is crucial for managing large-scale infrastructure.
Yeah.
Now, mastering Terraform highlights a key consideration here. The values we use for count or for each need to be known at plan time.
What does that mean? Can you explain it in a way that even I can understand?
Sure. It means that we can't use values that are only available after the infrastructure has been created.
Okay.
Right? Imagine trying to use the IP address of a server as input for count.
Right.
That IP address wouldn't be assigned until the server is actually running.
Right.
It'd be like trying to bake a cake before you've bought the ingredients.
Okay, that analogy makes perfect sense. We need all the ingredients ready before we start baking, or in this case, creating our infrastructure.
Exactly. Terraform in depth dives into some workarounds for this limitation, such as using data sources to retrieve information that might not be available until runtime. But the key takeaway here is that we need to think about the order of operations and ensure that the information Terraform needs is available at the right time.
This is getting pretty deep, but I'm loving it.
Good.
It feels like we're peeling back the layers of Terraform and,
Yeah.
and understanding how it works. It's magic.
I'm glad you're enjoying the deep dive.
Yeah.
Now, there's another aspect of Terraform that can be, you know, a bit tricky, but is sometimes necessary, and that's state manipulation.
State manipulation. That sounds a bit like brain surgery for our infrastructure.
What?
Why would we ever need to do that?
Well, there are legitimate reasons, such as refactoring our code or removing a resource from Terraform's management without actually deleting it from our infrastructure. Terraform in depth highlights a couple of common scenarios where this might come up.
So if we decide to reorganize our code or stop managing a particular resource with Terraform, we might need to tweak the state file to reflect these changes?
Exactly. But both of our sources really emphasize that state manipulation should be done with extreme caution.
Okay.
If not handled properly, it can lead to inconsistencies and potentially even damage your infrastructure.
It sounds like we're venturing into dangerous territory here. Is there any way to mitigate those risks?
Well, mastering Terraform suggests considering tools like Terraform Cloud,
Okay.
which can provide a more controlled and secure environment for managing state and collaborating on infrastructure changes.
Okay. So it's not something to be taken lightly.
No.
But there are tools and techniques that can
Right.
help us do it safely and effectively if it's absolutely necessary.
Absolutely. Now, let's talk about another important aspect of state management. It
Okay.
can be a real game changer for teams, and that's remote state.
Remote state. Does that mean storing our state files somewhere other than on our local machines?
You got it. Terraform in depth dives into the various benefits of using a remote backend
Yeah.
for storing state files.
Okay.
It's particularly useful for collaboration because it provides a single source of truth for the entire team.
So instead of everyone having their own local copy of the state file,
Yeah.
which could lead to conflicts and confusion,
Right.
we can all work from a shared remote state file.
Exactly. And there are, different back-end options available from cloud storage services like AWS S3 or Google Cloud Storage to dedicated Terraform backends like HashiCorp console.
Okay.
It's all about choosing the approach that best suits your team's workflow and security requirements.
This remote state concept sounds like a real game changer
Yeah.
for teams working on, larger projects. It's all about bringing that collaboration
Wow.
and version control that we see in software development to
Yeah.
the world of infrastructure.
Precisely. And this brings us to another powerful feature in Terraform.
Okay.
That mastering Terraform really explores workspaces.
Workspaces. What are those and how do they relate to remote state?
So workspaces allow you to create isolated environments within your Terraform project.
Okay.
Think of them like separate branches in a Git repository.
Okay.
You can have a workspace for development, one for staging, and one for production, all using the same code base, but with different configurations or variables.
So it's a way to manage different environments without having to create completely separate Terraform projects.
Exactly. And when combined with remote state,
Right.
workspaces become even more powerful because each workspace can have its own isolated state file stored in the remote backend.
This is all incredibly insightful. We've covered a lot of ground in this part, from security best practices and building custom modules to the intricacies of looping, state manipulation, remote state, and workspaces.
We have. It's a testament to how versatile and powerful Terraform is. And it's amazing how both our sources, complement each other,
Yeah.
providing both practical guidance and a deep understanding of these concepts.
Well, I'm ready to level up my Terraform skills even further. What's next on our deep dive adventure?
Well, in part 3, we'll venture into some of the more advanced and specialized areas of Terraform, including testing, continuous integration and delivery, and even building our own custom providers.
Sounds like we're going to be pushing the boundaries of what's possible with Terraform. I can't wait. Welcome back to the deep dive. We've explored the foundations of Terraform, dove into those real-world applications,
Right.
and now it's time to unlock some of its most advanced capabilities.
Yeah. Today, we'll be venturing into the realm of testing, automation, and even custom provider development, the tools and techniques that separate the Terraform apprentices from the true masters.
I love that analogy. But testing infrastructure, that sounds a bit different from testing traditional software.
Right.
How does that even work?
You're right. It's a different beast, but the principles are surprisingly similar. Just like with software, We want to ensure our Terraform code does what it's supposed to. It creates the right resources and behaves as expected.
So we're not just writing code and hoping for the best, right?
Right.
We're actually verifying that it works
Right.
as intended.
Exactly. Terraform in depth outlines several approaches to testing our infrastructure code. Unit testing focuses on individual components or modules,
Okay.
while integration testing checks how those components interact with each other.
Right.
And end-to-end testing validates the entire system's behavior.
It sounds like we can borrow some of the best practices from software testing
Yeah,
and apply them to the world of infrastructure.
absolutely. And both our sources introduce us to some powerful testing frameworks specifically designed for Terraform.
Okay.
Terratist, for example, is a Go-based framework that's become quite popular in the Terraform community.
Yeah, Mastering Terraform dives into Terratist and provides some, great examples of how to use it. What are some of the advantages of using a dedicated testing framework like Terratist?
Well, Terraform in depth highlights several key benefits. For example, Terratist can automatically clean up the resources created during testing,
Okay.
which is crucial for avoiding unnecessary costs and keeping our cloud environments tidy. It also provides mechanisms for setting timeouts, ensuring that tests don't run indefinitely if something goes wrong.
That's a relief. I wouldn't want a failed test to leave, a bunch of servers running, racking up a huge cloud bill.
Right.
Right.
Exactly. And both sources really emphasize the importance of treating our tests with the same rigor and discipline as we treat our main Terraform code.
Right.
We should version control our tests, run them regularly, and integrate them into our CI/CD pipelines.
Speaking of CI/CD, it's become such an essential practice in modern software development. Can we apply those same principles to
Yes.
IAC using Terraform?
Absolutely, yeah. Both Mastering Terraform and Terraform in Depth really advocate for incorporating Terraform into continuous integration and continuous delivery pipelines. Instead of manually running Terraform commands, we can automate the process of testing, validating, and deploying our infrastructure changes.
So we're talking about automating the entire workflow
Yeah.
from code changes to infrastructure updates.
Yeah.
That sounds incredibly efficient.
It is. Terraform in Depth walks us through setting up a basic CI/CD pipeline using GitHub Actions.
Okay.
It's a popular platform that allows us to define workflows that are triggered by events like pushing code to a repository or creating a pull request.
So imagine this, a developer pushes a change to their Terraform code.
Right.
The CI/CD pipeline automatically kicks in, runs the tests, and if everything passes, deploys the changes to the infrastructure. It's like magic.
It is pretty magical.
Yeah.
It's a game changer for teams looking to streamline their IAC workflows, improve collaboration, and increase the reliability of their deployments.
Okay, I'm sold on CI/CD for Terraform. But now let's talk about something that sounds even more magical, creating our own Terraform providers.
Right.
Is that even possible?
It is. It is, and it's one of the most powerful features of Terraform. Terraform in Depth dedicates a whole chapter to this topic.
Yeah.
Really demystifying the process
What?
and making it accessible even for those who aren't seasoned Go developers.
Hold on, Go developers, you're telling me I need to learn a whole new programming language to create a Terraform provider?
Don't worry. It's not as daunting as it sounds.
Okay.
The book does a fantastic job of guiding us through the process,
Right.
step by step.
Okay.
And remember, the ability to create custom providers opens up a world of possibilities.
I'm intrigued. Why would we even want to create a custom provider in the first place?
Well, there are a few scenarios where it makes sense. Sometimes there simply isn't an existing provider for a specific service or tool that we want to manage with Terraform.
Right.
Or we might have internal systems or custom-built applications that we want to bring under Terraform's control.
So it's about extending Terraform's reach
Yeah,
beyond what's already available in the public provider registry.
exactly. And to make it even more concrete, the book walks us through a real-world example, creating a custom provider for Mastodon,
Okay.
a decentralized social media platform.
That's a great example. So we could potentially use Terraform to manage our own Mastodon instance, or
Yes.
even create modules for others to use.
Absolutely. The possibilities are really endless when you start thinking about custom providers.
Right.
And Terraform in Depth doesn't just stop at building the provider.
Yeah.
It also shows us how to test it thoroughly,
Hmm.
package it up neatly, and even publish it for others to use.
Yeah. Wow, it's like going from like a Terraform user to a Terraform contributor,
Yeah. Yeah.
sharing our creations
Yeah,
with the world.
exactly. And this brings us back to Open Tofu, the open source fork of Terraform we discussed earlier. Terraform in depth even provides guidance on contributing to the Open Tofu provider ecosystem, giving us even more options and opportunities to be part of this vibrant community.
This deep dive has been an incredible journey.
It has.
We've come a long way from those early discussions about the why of IAC to now exploring the depths of custom provider development.
It's amazing how both Mastering Terraform and Terraform in depth complement each other. They provide a perfect balance of practical guidance
Yeah.
and deep insights, equipping us with the knowledge and tools to truly master Terraform.
Well, I feel like I've leveled up my Terraform skills significantly. We've explored the power of its declarative approach, the flexibility of modules, the robustness of its testing frameworks, the efficiency of CI/CD, and the extensibility of its provider system.
And most importantly, we've seen how these concepts can be applied to solve real-world infrastructure challenges, bringing order, efficiency, and security
Yeah.
to the way we manage our systems.
What a journey. Thank you for joining us on the deep dive. We hope you've gained valuable insights and a newfound appreciation for the power and versatility of Terraform. Until next time, happy infrastructuring.